Have you ever pondered the mysteries of the universe and in particular the enigmatic black holes? These cosmic entities are a fascinating mystery of the cosmos, captivating us with their sheer power and seemingly impossible nature. Black holes, in essence, are regions of space-time where gravity reigns supreme. Their gravitational pull is so intense that it ensnares everything that ventures too close. And when we say everything, we mean everything. From stardust to light itself, nothing escapes the clutches of a black hole. Yes, you heard right, not even light. The fastest thing in the universe can outrun a black hole's gravitational field. This is why they are called black holes. They are invisible to the naked eye, shrouded in a darkness so profound, it mirrors the enigma they represent. So it begs the question, doesn't it? If they're practically invisible and gobble up everything in their vicinity, how did we come to know about these cosmic enigmas in the first place? The concept of black holes was first introduced in the 18th century, but the term itself wasn't coined until much later. Let's journey back to the year 1783. A man named John Michell, a British natural philosopher, was the first to theorize the existence of dark stars. Celestial bodies so dense and with such strong gravity that not even light could escape. He presented this radical idea to the Royal Society of London, and although it was met with intrigue, it was largely theoretical at the time. Fast forward to the early 20th century, a time of remarkable scientific advances. In the year 1915, Albert Einstein, a name synonymous with genius, presented his general theory of relativity to the world. This groundbreaking theory further predicted the existence of these dark stars, which we now know as black holes. Einstein's equations suggested that when a massive star dies, it leaves behind a small, dense remnant core. If the core's mass is more than about 3 times the mass of the Sun, the equations showed, gravity would overwhelm all other forces and create a black hole. However, it wasn't until the year 1971 that we first laid our metaphorical eyes on a black hole. Astronomers discovered an X-ray source in the constellation Cygnus, named Cygnus X1. This celestial object was found to be about 15 times the mass of our Sun, packed into a region no larger than a city. The overwhelming evidence led scientists to conclude that Cygnus X1 was indeed a black hole, the first ever to be discovered. From a theoretical curiosity in the 18th century to a confirmed cosmic phenomenon in the 20th, the discovery of black holes has been a fascinating journey of human curiosity and scientific exploration. Every step of this journey has been driven by our inherent desire to understand the universe and our place within it. And so, the existence of black holes was confirmed, but what makes them so fascinating? At the heart of a black hole lies its singularity. A black hole, in essence, is a cosmic trapdoor from which nothing, not even light, can escape. It's an enigma that continues to baffle and intrigue us. But what exactly makes up a black hole? Let's start with the event horizon. It's the point of no return. Once anything crosses this boundary, it's doomed to be consumed by the black hole. The event horizon is the ultimate one-way street, leading only towards the black hole's center. Next, we come to the accretion disk. This is a flat, rotating disk of matter spiraling into the black hole. It's similar to water circling a drain, but on a cosmic scale. As this matter spirals in, it heats up and emits a brilliant light, creating a luminous halo around the black hole. And then we have the singularity. It's the heart of a black hole, a point of infinite density where our understanding of physics breaks down. Here, space and time as we know them cease to exist. It's a location where the universe's most extreme conditions exist. Now picture this. You're falling into a black hole. As you near the singularity, you'd experience something called spaghettification. This is where the gravity at your feet is so much stronger than at your head that you're stretched out, like a piece of spaghetti. It's a strange and fascinating concept that comes from the intense gravitational field of a black hole. So, a black hole is not just a void in space, it's a complex structure of event horizons, accretion disks, and singularities. It's a place where light ends and mystery begins. It's a place where our understanding of the universe is continuously tested and expanded. Now that we have a basic understanding of what a black hole is, let's delve deeper into some of the latest findings. The study of black holes is a rapidly evolving field, with new discoveries being made every year. One such groundbreaking discovery was the first ever image of a black hole, captured in 2019 by the Event Horizon Telescope, a global network of observatories. This remarkable achievement gave us a glimpse into the heart of a supermassive black hole located in the M87 galaxy, 55 million light-years away from us. The image, though blurry, is a visual confirmation of Einstein's general theory of relativity, which predicted the existence of these enigmatic cosmic phenomena. In addition to this, scientists have been delving into the fascinating world of mini black holes. These are theorized to be as small as a single atom, yet with the mass of a mountain. The existence of these mini black holes could potentially explain the mysterious dark matter that makes up about 25% of the universe. Another groundbreaking discovery was made when we detected the ripples in the fabric of space-time, known as gravitational waves from black holes colliding. This spectacular event occurred about 1.3 billion years ago, but we only detected it in 2015. This detection confirmed another of Einstein's predictions and opened a new window to observe the universe. The research doesn't stop there. Scientists are tirelessly working to unravel the mysteries of black holes. Theories related to dark matter and quantum gravity are being explored. For instance, some researchers propose that black holes could be made of dark matter. Others theorize that studying the event horizon of black holes could give us insights into quantum gravity, a theory that aims to reconcile quantum mechanics with general relativity. These are indeed exciting times in the field of black hole research. Each discovery brings us closer to understanding the nature of our universe and our place within it. Despite all these discoveries, black holes still hold many more mysteries waiting to be unraveled. The exploration of black holes doesn't stop here. It's a journey that may lead us to understand the very nature of our universe. As we step further into the future, black hole research continues to open up new frontiers of understanding. One such frontier is the study of black hole thermodynamics. By investigating the heat, energy, and entropy of black holes, scientists hope to gain insight into the fundamental properties of these cosmic phenomena. Just as thermodynamics revolutionized our understanding of heat and energy, so too could black hole thermodynamics reshape our understanding of the universe. Meanwhile, astronomers are on a ceaseless quest to capture more images of black holes. Each new image is a treasure trove of data, shedding light on the elusive nature of these cosmic beasts. The first image of a black hole, revealed to the world in 2019, was just the beginning. The future promises even more detailed images, potentially revealing the intricate details of the black hole's event horizon and jet structures. Another exciting area of future research is the quest to understand what happens inside a black hole. This is one of the most intriguing mysteries in physics. The laws of physics as we know them break down inside a black hole, leading to intriguing questions about the fundamental nature of reality. Could there be a new physics waiting to be discovered within these cosmic enigmas? But it's not just about pure research. The practical implications of black hole studies could be profound. Advancements in technology, from communication systems to energy generation, could be spurred by insights gained from this research. Moreover, understanding black holes could help us comprehend the ultimate fate of the universe itself. As we continue to probe these cosmic mysteries, who knows what other secrets of the universe will be revealed? The future of black hole research is a thrilling frontier, filled with potential discoveries that could transform our understanding of the cosmos and our place within it. Black holes, once just a theoretical concept, have become a fascinating and integral part of our understanding of the universe. They were first discovered through mathematical equations, and later, their presence was confirmed by direct observation. These cosmic anomalies are not just voids in space, but rather complex structures with an event horizon, singularity, and even a photon sphere. Recent research has unveiled astounding findings. For instance, the detection of gravitational waves has opened up a new way of studying these cosmic giants, but black holes still hold many secrets. The future of black hole research is brimming with potential, with scientists striving to unlock the mysteries they hold. From the idea of their existence to our current understanding, black holes have always intrigued us. They remain one of the most captivating subjects in cosmology. As we stand on the brink of new discoveries, black holes continue to captivate us, reminding us of the infinite possibilities that lie in the mysteries of the cosmos.